over algebraic representations again. This time we're going to talk about the rules. So last time we kind of talked about it, but this one let's really go in depth into the material. So before we do that, let's go or do now. The rule 3x, where x is her brother's ticket, can be used to find Jamie's number of tickets. Make a table to identify the number of tickets Jamie has when her brother has 40, 50, and 60 tickets. Then graph the order pair. So Jamie's brother has 40, 50, and 60 tickets. The relationship, this time they gave it to us. They're all so nice to us. Last time we had to figure out the relationship. This time the relationship is 3 groups of the tickets. 3 of the tickets. So there are 3 times, 3 times, 3 times, 3 groups. So if her brother Jamie has 40 tickets, what's 3 groups of 40? 120 tickets. If her brother had 50, 3 groups of 50 is 150. If her brother has 60, 3 groups of 60 is 180. It's time to graph it. So, in case you forgot, this is the independent, which is the x-axis. The y-axis is dependent. Why is this dependent? Jamie tickets depends on how many her brother has. So if her brother has a lot of tickets, she'll get a lot of tickets. So this is the independent, and this is the dependent. So let's see. Jamie's brother has 40 tickets. That means she will get to have 120 tickets. Jamie has 50 tickets. Brother has 50 tickets. That means she'll get to have 150 tickets. And if her brother has 60, she will get to have 180. So dependent is Jamie's ticket. Independent is Jamie's brother's ticket. So as you can tell, when her brother has 40, you triple. That's the number of tickets that Jamie gets to have. So what are the independent and dependent variables? The independent is the x-axis. That's Jamie's brother. That means the dependent is Jamie herself. Yes, Jamie's gets. So, can you write a statement explaining what's happening here? As you can tell from this, as Jamie's brother increases, so does the number of tickets for Jamie. Good for her. So I'm going to write that down. As Jamie's brother tickets increases, so does the number of tickets, so does the ticket numbers for Jamie. Because another way you can explain it, as Jamie's brother increases, as Jamie numbers ticket increases, it dependent on the increase of Jamie's brother's ticket increase. So today we're going to talk about patterns, sequences, like different patterns. A pattern can also be called a numerical sequence using numbers. So it's a list of things, usually numbers that are in order. For example, these numbers are in order, 3, 5, 7, 9. So it's going by counting by 2, as you can tell. And the first term, or the first number, is 3. Second term is 5. Third term is 7. Fourth term is 9. 3 dots mean it goes on forever. It's infinite. In an arithmetic sequence, you just add some value each time onto infinity. So, for example, in this one, you just keep on adding 8 over and over and over. Add 8 to the previous term. That's arithmetic, because you're doing math, arithmetic. For geometric, you are building it up. You are multiplying by some value. In this one, you're tripling. So you're multiplying all the numbers by 3. So sometimes you might hear me using the word arithmetic sequence or a geometric sequence. So as long as you can figure out the pattern, if you can't really memorize these words, as long as you can find the pattern what it's going by. Is it increasing by adding or is it increasing by multiplying? So use words and symbols to describe the value of each term in relation to its position. So you're going to help me find a relationship here. The third position of the number is 11. The fourth position or fourth number is 12. The fifth number is 13. What is happening? What's the relationship here? I think it's increasing by 8. So it must be arithmetic. So it's increasing by 8. So we're adding 8 to each position. We're adding 8 to each independent variable. Remember, independent, dependent. So we're adding 8. That is the rule. That's how I would describe the value, what's happening. And then the question is, find the value of the ninth term. So 3, 4, 5, if it's the ninth term, and we keep on adding 8, the ninth term will be 17. Next one, 5, 6, 7. The fifth position or fifth number will be 45. The sixth number will be 54. The seventh number is 63. What is the relationship here? What's happening here? Well, it's increasing. By adding or by multiplying? You know what? I think it's increasing by multiplying. I think you're building it up by 9, building it up by 9, building it up by 9. So you're building it up by 9. So the rule is you're multiplying the number by 9. Another way to rewrite that is 9 groups of the number. So both of these are correct. You can say n times 9, but most of the time you will see it as this, 9 groups of that number. So what is the ninth number? So we have the ninth number, and since we're multiplying by 9, it will be 81. The ninth number of this pattern will be 81. So, with a partner, describe the independent quantity, dependent quantity, and expression. What's happening in a relationship? So we have -1, it goes to 3. 0 goes to 0. 1 goes to -3. 2 goes to -6. What is happening here? What is the relationship? I don't know. Well, I know it's not adding anything because how can you add 0 to something and get 0? I bet you it's multiplying. Oh, what do you multiply 1 by to get -3? I think it's -3. I think that is the relationship here. You're multiplying by -3. So in case you forgot the thing, multiply or divide is an easy thought. Same signs are positive. That's why it's positive. Different signs are not. So the relationship is multiplying by 3. So let's see. Independent is x. Dependent is y. Again, independent is just the first of the table. Dependent is the second one of the table. It's x and y. So what is the expression rule? So in here, you have x. What are you doing to these numbers? You're multiplying by -3. So it's x times -3 or -3x. Either one. This is more preferred. That means you're tripling it by x, with a negative number. You're negative triple by x. Next one. I have cups of sugar and dozen cookie. Find the relationship. First of all, what is the independent? Cups of sugar and dozen of cookies are the dependent. So what is the relationship here? Ooh. No, I'm going to start looking at whole numbers. I don't like looking at a fraction. I know you're multiplying by 4. Let's make sure. 4, 1, 3 times 4 is 12. 4 times 1 is 4. 12 divided by 4 is 3. So it is. You're multiplying by 4. So what is the relationship, the rule here? So we have cups of sugar. So if you use the letter C, you are doing C times 4 or 4C. That means 4 groups of the cup of sugar. You're multiplying by 4 to get how many cookies? Next one. All right, what is the independent? Miles driven and gallons used. Why? The number of gallons used is depend on how many miles you drive. That's why this is dependent. So what is happening here? Well, first of all, I think it's building up so quickly, it's going to be multiplying by something. Multiplying by something. I do not know what we're multiplying by. So let's divide. Opposite multiply is divide. So how many 5s go into 116.5? So it goes in 2 times, goes in 3 times, it goes in 3 times. So you're multiplying by 23 and 3/10. You're multiplying by 23 and 3/10. You're building it up to that to get the gallons used. So it's miles driven times 23.3. That's how many miles driven times 23.3. So if you drive each mile, determine how many gallons you use. And so on. So it's 23.3 miles. You know what I was thinking? These numbers should have been reversed. Because it doesn't really make sense here. But, oh well. Yeah. So I think I'm going to tell my class when they come to class, to reverse these two numbers here, because if you use 5 gallons, you would drive 116.5. So next one, number of weeks shows how much growth. So what's happening? What's the relationship here? What's the relationship here? So, wait, let me go back here. 5. Oh, this must be no, it makes sense. This is like a big heavy duty airplane, like a jumbo jet that probably they go 5 miles. They use tons and tons and tons of like a cruise liner. That just makes sense, right? It does make sense. I'm thinking of cars for some reason because I drive a Corolla and I don't use that many gallons of gas to get the miles. So this is actually correct. So next one, number of weeks. In 1 week, you grow half an inch. 2 weeks, you grow 1 inch. So what is happening here? First of all, the independent is weeks, and the dependent is growth. The growth is dependent upon how many weeks have passed. So what is the expression? I think it's dividing by 2, dividing by 2, dividing by 2, dividing by 2. Another way to say it is times a half, times a half, times a half, times a half. Because half of 4 is 2. So the relationship is weeks divided by 2, or you could say weeks over 2, or you could say weeks times 1/2, or 1/2 the weeks. Either 1/2 of the weeks. Half of the weeks in order to figure out the growth. Next one. So number of slices and total cost. The independent is slices, dependent is cost. So cost is dependent on how many slices you buy. So what is the pattern here? So it's building up from 2 to $3.50, 4 to $7. I have no idea. How many 2's going to do $3.50? It goes in, let's see, $1.75. So from what I can tell, it costs $1.75 for each slice. So 2 slices will cost you $3.50. 4 slices for $1.75 will cost you $7, so on. So what is the relationship, the rule here? You're multiplying the slices by $1.75. Or in other words, it's $1.75 per slice. $1.75 groups of slices. And that's it. So in this one, we practice identifying what are independent and dependent, just like we did in our last lesson. And now we're finding more of the relationship. Can you tell me the relationship from the first to the second? It's either by multiplying or by adding. You're building up through multiplying or building up by adding. So this is algebraic representations through rules.